Welcome to another video. In today's video we are going to solve generating all permutations problem from the Leetcode. In this problem they will pass a list of numbers in which all the numbers will be unique, and we need to generate all the permutations from the given list. And if you observe this first example, permutation is nothing but when we rearrange the elements which are present in the original list, we will get a permutations. So these are all the permutations of the given list. So we need to return all the permutations for a given list, and in the problem constraints it is mentioned that all the numbers which are present in the given list are unique. Keeping these things in mind, and let us go through our drawing board to understand how we can write a recursive solution to generate all possible permutations. Let's go through an example to understand how we can generate all the permutations for a given list of unique numbers. We will start with the original list, and then we will start swapping the numbers. Initially we will start with index 0, and we will swap this position with the same position. So we will get 1, 2 and 3 as result, and then we will swap these two positions. We will get 2, 1 and 3, and after that we are going to swap first and third position. We will get 3, 2 and 1, and here we started from index 0, and here we will start swapping from index 1. So after swapping 2 with 2, we will get 1, 2 and 3, and when we swap this 2 and 3, we will get 1, 3 and 2. And here also we should start with index 1. If we swap 1 with 1, we will get 2, 1, 3, and if we swap 1 and 3, we will get 2, 3 and 1. And here also we will start with index 1. If we swap 2 with 2, we will get 3, 2 and 1, and if we swap these two numbers, we will get 3, 1 and 2. So if you observe all these lists which are present in this level, we can see that all these are permutations of the given list, that is 1, 2, 3. So we are going to write a function in which we will follow this procedure with the backtracking, so that we can get all possible permutations. Only tricky thing here is we need to make sure from where we are starting. Initially we will start with index 0, and we will swap this number with this number and this position and 1 and 3. And here we are starting with, on the second level, we are starting with index 1, and we will start swapping from there. Initially we will swap this number with the same position, so we will get this permutation, and then we will swap these two positions, we will get this. And similarly for this permutation also, we will start from I equals 1. So here also if we swap this number with the same position, we will get this thing, and when we swap these two positions, we will get this permutation. So this is the overall logic behind generating all these permutations. Let us implement the same thing using C++ programming language. Let's implement the same solution that we have discussed here. So initially we are going to start with index 0, and then we keep on swapping based on the starting index. So we will implement the same thing here as well. So initially we will declare one more public variable to store all possible permutations. And here we are going to call generate permutations with a starting index of 0, and we are going to pass nums for that function. And finally that function will in turn update this particular permutations we are going to implement that function as well, and then we will return permutations. So only thing pending here is we need to implement this. It is not returning anything. We just need to implement generate permutations function. The first argument that we are getting here is start index and nums. This is kind of straightforward here. As we have noticed here, we will perform swapping from for 0 to 1. So if we reach I equals to 2, that means n minus 1, there are 3 elements here, n is 3, and at this position we don't do any swapping. So we will continue swapping only till I equals n minus 2. So we will check if start index equals nums dot size minus 1. So that means we are here in this level. So at this level we already have that permutation. We need to push it to our answer. So what we are going to do is permutations dot push back nums, and then we are going to just return from here. Otherwise we will start swapping from that start index to till the end position. So we are going to write a for loop for that swapping. Int I equals start index to I less than nums dot size I plus plus, and here we will use this function. We are going to call nums of start index with the nums of I. After swapping, we are going to call this function recursively here, because once we swap here we are going to call this function recursively. So this is what we are doing here. So we will call generate permutations with, we need to increment start index because we have already swapped, and nums. And after that, once this completes, we need to, once all of these calls gets completed in recursion, while going back we need to swap again to reset to original position. This is common in every backtracking problem. So we have to swap again. Swap nums of start index and nums of I. So why are we swapping again? This is because here, if you observe here, we will swap 1 with 1 and we will get this, and we will swap 1 with 2, we will get this. And while getting this, we are not considering this particular combination. We will start from here. Even though we reach here at this position, once again we will, while going back in the recursion path, we will reset to this position, and from this position we once again swap and we will get this. So this is what backtracking actually is. And if you could realize how function calls are going to take place in recursion, that would be great. So this is the overall approach to this problem, and let us submit this solution and check whether it passes initial test cases or not. Okay, here we are getting some, I think if we get used to Python coding, we will miss out certain things. This is one such thing. Okay. Yes, as you can see here, this solution is passing initial test cases. Let us submit this solution and check whether it passes all the test cases or not. Yes, As you can see here, this solution is passing all the test cases. If you are interested in learning more about other data structure and algorithm related problems, you can check out other videos from my channel. Thanks for watching this video.